Okay, let's take a look at a possible reaction here. All these reactions that we deal with solutions generally happen in double displacement or double replacement format. Okay, so what we're going to do is we're going to take a look at these two reactants, and if I were to look them up on my solubility chart, I would notice that both of these would say AQ, which means they're both capable of making solutions. It's something that both of them will dissolve in water. Okay, so I'm going to write AQ next to both of them. And all that's signifying is that we're going to dissolve them in water before we actually put them together. Okay, now your same old habits apply. The things you've done for months now. We're going to look up the oxidation number or the charge on silver, and it's a +1. We look up nitrate, and it's a -1. Okay, those fit together nicely. One of each will make a neutral compound, so I write 1 silver and 1 nitrate. But remember, nitrate is one of those groupings, and its formula is NO3. I'm going to write AQ, which means before we put it with anything else, we're going to dissolve it in water. Now I'm going to do the same thing with sodium phosphate. Sodium is a +1, phosphate's a -3. Okay, now those don't fit together nicely, but we know if we just had 3 sodium ions combined with 1 phosphate ion, it would make a nice neutral compound. So I'm going to have 3 sodiums and 1 phosphate, and phosphate is PO4. Okay, now that's also AQ, aqueous. So both of these are dissolved in separate containers of water. They get broken apart into ions. They kind of float around, and most of the time they're even invisible. You can't really tell they're there, but they're there floating around in solution, but they're broken apart. Now, when we put those two containers together, it gives things the option, the capability of recombining in a different way. So let's look on paper what we would normally do. Silver is going to be able to combine with phosphate. Sodium is going to be able to combine with nitrate. So I'm going to write silver, phosphate. Then I have to look at these charges again. Silver's a +1, phosphate's a -3. I'm going to need 3 silvers to go with that 1 phosphate. The other product is sodium nitrate. I've got sodium and nitrate, but this is a +1 and a -1. Okay, that's nice. That fits together, so I only need 1 of each. Now, I got to balance these amounts before I really do anything else. I have 3 silvers here, so I'm going to have to put a 3 in front of the silver. Now that 3 also applies to nitrates. I got 3 nitrates, so I'm going to need a 3 over here to give me 3 nitrates. That 3 also applies to sodium, but I have 3 sodiums on this side. Remember, that's not an accident, that's chemistry. And I got 1 phosphate on each side. So really I have a 3 to 1, a 1 to 3 ratio. Now, that's the mechanics. Let's look at the bigger picture here. Okay. If I take a look at these products and I look on my solubility chart and I go identify those combinations, I'm going to notice that silver phosphate, if I go silver all the way across to phosphate and come down here, it says it's an S. It means it's a solid. When I look up sodium nitrate, it says AQ. It's aqueous. Now look what that means here. We took 2 separate solutions with everything dissolved and broken apart in water. We dump them together, and all of a sudden this solid, like chunky kind of gooey stuff forms. Okay, that's something new. So this is called a precipitate. Okay, and it's labeled PPT as the abbreviation, but that's important. These are called precipitation reactions. If this reaction actually happens, we should see some solid gooey stuff come out of it. So when you're doing your homework, I want you to not only write the balanced equation, but identify which one of these products is the precipitate. Now this one says AQ. It's nothing special. It's just still dissolved in water, which means it's floating around in this clear liquid that's in there. It's in the solution, but it doesn't really come together to make anything new. Sodiums and nitrates, they were floating around in water before they started, and they're floating around in water when they're done. We call those spectator ions. They don't really do much. They're there and they have a purpose, but they don't really change at all. Okay? So this is what we're looking for in our homework. Be able to write the balanced equation, get all the numbers correct, and then look up your products and see which one of these would be a precipitate. Which one's that solid stuff. Now, will a precipitate always form? Not necessarily. Let me show you an example. Okay. Now I'm going to do this one a little bit faster just to save time, but it's the same process we did before. If we just started writing this like we're kind of used to doing, you just kind of start doing chemistry, we would see ammonium chloride is NH4Cl. It's aqueous. Potassium bromide is KBr. It's aqueous. I can easily on paper take ammonium and say it's going to combine with bromide, potassium is going to combine with chloride, and I can write those, NH4Br and KCl. Okay, and this is normal, and all these are 1-to-1 ratios, so I get lucky with the numbers here. However, when I try to interpret the reality of it, I look on this, and I'm going to notice that both of these are aqueous. Now what does that really mean? Okay, this right here was a solution where water had ripped these two components apart and they're just floating around separate. Same here. So basically these 4 ions are just floating around in water. Well, when I put them together as one container, I still just have all 4 ions floating around in water. Nothing actually combined. I can write this on paper, but it doesn't mean it actually happened. So this is kind of a phony situation. There is no precipitate. And if you get no precipitate, then you really, in essence, have no reaction. Okay, I want you to look for some of this happening on occasion in your homework. Sometimes you put them together and you don't get anything really occur. They just mix into the same container, but they don't really actually bond and form something new. Now the trick is to notice it before you start, to be able to look over your 2 reactants, take a look at your solubility chart. They should both be aqueous, but then kind of in your mind, go to here. See, what are the possible combinations it could make? Are any of those going to be solid? And if I don't get any solids anywhere, then really I'm just mixing 2 mixtures together, but nothing new actually happens. And I can notice that it's a no reaction before I ever start. And there's no reason to bother writing a balanced equation for something that doesn't happen. We might as well just write no reaction. So that's what you're looking for in your homework. Occasionally, if one of these doesn't make a precipitate, just write no reaction. Don't bother with the entire equation.